So we're making our way through the mole topic and chemical calculations. So this may be a good time to do a little quiz to make sure that you've got everything that we have covered so far before we start moving on to new areas of the mole. So here we go. On the first few pages will be the questions, and then I'll go for the answers. As ever, you can download these slides from the website. So here's our first page of questions, question 1 and 2, where we'll be looking at balancing equations and also working out the correct formulae. So you can pause if you like and do it, or as I said, download the worksheet. Questions 3 and 4 are looking more at calculating moles and masses, and also thinking a little bit about what the mole means in question 4. Here are the final set of questions, and these will all relate to reactive masses or volumes. So, coming up are the answers. So, hold fire if you haven't quite managed to get through them yet, or have a look at the worksheet, and we will go through them coming up now. So the first thing we're going to do is balance some equations. So here we go. Obviously this is a key thing to get right, otherwise everything else will go horribly wrong. First one, we need two HNO3s to make that balance. Key clue there is, of course, you're forming H2 here and also two NO3s there. Let's have a go at the next one. We're going to need two sodium hydroxides and make two sodium chlorides for that to be balanced. For C, two SO2s and two SO3s to become balanced. And our final one is 5 oxygens, 3 carbon dioxides, and 4 waters. So now it's time we have to not only balance the equation, but also make sure we have the formulae right. A few to catch you out there, but I'm sure you spotted them. So first one is sodium and oxygen. Remembering oxygen is diatomic, so we need to write it as O2. Formula of sodium oxide Na2O, and those numbers balance it. Aluminium and chlorine, again chlorine is diatomic, and that forms aluminium chloride, AlCl3. Calcium and hydrochloric acid, quite straightforward. Just make sure you get those formulae right. Again, hydrogen is a diatomic gas, so we need to make sure that's right. And the final one is ammonia plus sulfuric acid to give ammonium sulfate. We need 2 ammonia molecules to make sure that one balances out. So now we're going to calculate the mass of a couple of substances. The first one is we have 0.1 moles of hydrogen gas, so we need to calculate the mass. Mass, of course, is moles over times molar mass, rather. Molar mass of H2 is 2, so that gives us 0.2 grams. The molar mass of sodium bromide is 103. We have 0.2 moles, so we times those two numbers together to give us 20.6 grams. We're now going to calculate moles from mass, so moles is mass over molar mass. So for iron, it's 0.15 divided by 55.84 to give us 2.67 moles. And sodium sulfate, we divide our mass by 142 to give us 0.00880 moles. So this was a little bit of a cheeky question. 4A shouldn't be too bad. We have to find the number of moles of sulfuric acid if in 98.1 grams, and that is 1 mole. So that's not too difficult. But then it asks how many moles of H plus ions does that contain? Well, if you look at the formula, in every one H2SO4, here we have 2 H plus ions there. So if I have 1 mole of sulfuric acid, I will have 2 moles of H plus ions, like so. So we have 2 moles of H plus ions. For sulfate ions, in every one H2SO4 there's 1 sulfate, so therefore I have 1 mole of sulfate ions. So for question 5, we need to find the volume of oxygen, which will ignite 20 grams of hydrogen. So first thing, we need to find our moles of hydrogen. So we can do that as mass over molar mass, which gives us 10 moles. We then look at the ratio, and if you look at the ratio between hydrogen and oxygen, 2 moles of hydrogen only require 1 of oxygen. So I divide my moles of hydrogen by 2 to give me 5 moles of oxygen, and then I need to find my volume. My volume is moles times 24,000, which gives me a volume of 120,000 centimeters cubed. So another reacting masses question. We now have 2.5 grams of sodium, and we need to find how much sodium oxide is produced. So again, find our moles of sodium, which is mass over molar mass. It gives us 0.109 moles. Our ratio between sodium to sodium oxide is 4 to 2. So I need to divide that by 2 to give me the moles of sodium oxide. And then finally, I need to find the mass of sodium oxide. So I times that by 62, which is the molar mass of Na2O, to give us 3.37 grams. So our final question. We have got 4 decimeters cubed of hydrogen sulfide, and it has been reacted with 10 decimeters cubed of oxygen, and we need to find the final volume of the mixture at room temperature and pressure. Okay, so let's have a think about this. If I have 4 decimeters cubed of hydrogen sulfide, I require 6 decimeters cubed of oxygen to react with it, because the ratio between hydrogen sulfide to oxygen is 2 to 3. So I take my volume of hydrogen sulfide, which is 4. I divide it by the number in front of hydrogen sulfide, which is 2, and times it by the number of the substance that I am trying to find the moles of, and that gives me 6 decimeters cubed of O2. And now if we look at the ratios of the other substances, we can see that 2 moles of hydrogen sulfide produce 2 moles of H2O and 2 moles of SO2. If I started with 4 decimeters cubed of hydrogen sulfide, I'd make 4 decimeters cubed of H2O and 4 decimeters cubed of SO2, because they're all 1-to-1 ratios. And I'm left over with 4 decimeters cubed of oxygen, because I started with 10 and I used 6, which leaves me with 4. And therefore my final volume is 12 decimeters cubed. So those were a few questions just to make sure that we were all fine on the videos we've done so far, because we're now going to move on to some other examples of using the moles in equations. As ever, you can download this worksheet from the website.